Molar mass is defined as the amount of grams of a substance in 1 mole of that substance. Calculating molar mass is pretty simple because this ratio of grams to moles is exactly the same as the amount of AMUs in each one of those atoms, and those numbers can be found on the periodic table. Let's do a few examples of calculating molar mass. Let's start with acetic acid. In this compound, we can see that we have 4 total hydrogens, 2 carbons, and 2 oxygen atoms. To figure out the total molar mass, I need to add up all of these masses from the periodic table. So I will do 4 times 1.008 for the hydrogen, 2 times 12.01 for the carbons, and 2 times 16 for each of the oxygens. Please note that each one of these values has units of grams per mole. Now all we need to do to find the total is add these up. Go ahead and give it a try on your calculator and make sure that you get 60.052 grams per mole for the acetic acid. Okay, next we're going to try this really epic mineral. Hydrate molecules like this can be a little intimidating at first because it's not just 2 elements, there's also some extra waters on top of there. And I'll show you how to handle that in a minute. First, let's write down our aluminum and oxygen atoms like normal. We have 2 aluminum. I'll write down the molar mass for the aluminum. And we have 3 oxygens on the first part of this ionic compound. So I'll write down 3 oxygen for now. Now the water part, this means that I have 2 separate waters. So I actually have 4 hydrogens and 2 oxygens from this portion of the molecule. Okay, so for this salty dude, let's add all these up. And for this one, we'll get 137.992 with those units of grams per mole on everyone again. The last compound that we're going to work on is a combination of an ionic compound with a polyatomic ion. This is also a great example to help us conceptualize what this little 3 is doing down here. This guy acts kind of like the 2 in front of the water, saying that we have 3 different sulfates. That means we have 2 aluminums, kind of like our previous example, but that we have 3 sulfurs in here. Let's find sulfur's number, 32.06. And we have 4 times 3 oxygens. So 12 times 16. Now let's add all of this up. And we get a really nice 342.14 grams per mole on everyone again. And that's the basics of how to calculate the molar mass for a bunch of different kinds of compounds.